We really wanted to try this out, this video conference thing, this video meeting thing. I think it could be a really valuable tool for us. We've got some assets with SummitGold that are really valuable to us. Dan and the guys from SummitGold are really, really good at what they do. We've been working with this company for since 1995 in one form or another. About 2001, it's been SummitGold, but learned a lot from this company. The products are, I believe, are secondary to what is really valuable, and that is the knowledge and understanding of simple soil science and gaining an understanding of how things work in the soil system. So that when you do that, when you start understanding what goes on in the soil system just a little bit, you begin to garner a lot of valuable stuff about being able to minimize other applied nutrients. You learn a lot about herbicides, what works well, what interacts with the soils, what is harmful. There's a whole systems approach that we look at. And through all that, we've been able to increase the overall health of our soils immensely. Granted, we're doing things like no-till, rotation, cover crops, but this program plays right along with all of those technologies and all those methods. And so we're really trying to, at the end of the day, what we're trying to do is stimulate the natural biological system in our soil. And Dan's going to go through a lot of the science today, and he's also going to talk about some soil tests and how to interpret those, or at least give you some semblance of what we do when we look at soil tests. We do it a bit differently than most companies do. We're not out to sell tons or lots of product. We look at the soil system first to see what it can chemically provide for you, and then we go from there. And then we kind of match our product lines with what we believe is going to help you at the end of the day. Increase yield, increase soil health, and increase profitability. Along with that, we've got some organic products now. We've got numerous certified organic products that I think some of you will find very interesting. We'll talk about products towards the end of the presentations. This is informal. Now, understand there's about a 2 to 3 second lag between what you see Dan talking and what you're going to hear. You're going to hear it before you see him say it. If you watch the presentation, I think you'll be better off. Anytime you guys have questions, just raise your hand, and I will stop Dan, and he will answer. We want to keep the question dialogue thing open at all times. So don't worry about time. We have as much time as you guys do. So with that, I'm going to introduce the company owners. You see Kurt on the left, on the right screen there. That's Kurt Fry. Greg Fry, are you around?
He's here. He's over here.
There's Greg. Okay, I got to know their dad, Dean. Dean is still a majority owner of the company. He's the one that I got to know 20-some years ago. And this is the company, guys. This is it. There's one other son, Jared, who is not in today. So there's 3 boys and Dean that own this company. And it's great to have them at my fingertips whenever I need something. Guy in the middle is Dan Kaufman. He's our certified crop consultant agronomist, one of the brightest soil people I've ever been around. And I've learned more from him than any textbook. I'm telling you, he's got a lot of wealth of information, and he's going to be doing the presentation today. So again, I appreciate your guys' time. We hope that it can be well worth your time to spend the next 2 hours or so learning a few things about what we do. So with that, I'm going to turn it over to you guys.
Yeah, so thanks everyone for coming. We do appreciate you guys taking time out of your day. Before I turn it over to Dan, I just wanted to again we welcome questions. Raise your hand, get Brian's attention. He'll get Dan's attention, and we'll definitely answer questions as we go. At the end, if there's more questions at the end, we'd love to have a little question answer time when Dan's finished, so we welcome that as well. We're going to talk a little bit about some products at the end. Brian's going to share specifics of what he's doing on his operation, and we definitely will talk some specific products. Towards the end of Dan's presentation, there will also be some products listed out on the slides. As far as a product you're going to see, it's called Complement. It is in your catalog that you guys have in front of you, and it's also going to be on a few of our slides. That particular product is not registered in South Dakota, and that's because South Dakota actually is one of our more difficult states to register products in. But complement is mixed into quite a few of our other products. If you see a product called SG Infuse, you'll see a product called Assist. There's a product called Convert. The microbes that are in complement are also in those products. So we did think it was good to talk specifically about that product so you understand what it is. And then when you're getting it in a mix, you're aware of that product. So I just wanted to clarify that. And with that, we're going to turn it over to Dan, and we'll talk to you guys here a little bit when we're finished. Again, thanks for coming today. Dan, go ahead and take it away.
All right. Well, thank you, gentlemen. I've been on a worldwide tour of Ohio all week, and so this will be about the 10th time I've done a presentation this week. So hopefully my voice makes it out for one more here 2-hour stretch, and we should be fine. A little different presentations all around. We've got growers just like yourselves all over the country that are fascinated with the biological industry and what it represents, how it's changing, how to integrate products just like these into their operations, recognizing that in the last year and a half, roughly $3.5 billion has been invested by several corporations across the country into this technology. And by 2022 to 2025, the estimates are a $15+ billion business. So as we start to talk about soil life, and all the other things that are happening in it, realize this is not a passing fancy. This is technology that has been now studied, researched, understood, and is now on the forefront of actually starting to be utilized. And in all things soils that we're doing here, what we are trying to do, as Brian mentioned before, is bring nature to bear into this whole operation, not because we necessarily have to, but what you'll find is as you bring it in, some of the efficiencies that nature brings us, we can't get other ways. There is no way to actually mimic what nature does with fertility and how it supplies fertility to plants with just fertilizer. It can't be done. There's a lot of other things involved. And so as we start to learn to integrate biology into the system, we find out that in many cases, much of the fertilizer that we've put in through the years that really has locked away and hidden away and does not show up on an available soil test can be released, and the plants find it. And I think people are kind of stunned when they realize how those things happen. So with that as a primer, I'm going to run down through this presentation. And as we said, if you have questions, get Brian's attention. We'll see how this thing goes. And I can always, I can stop anywhere in a presentation, and I should be able to help you help get answers to those questions. Okay. In our last second things before we start, Brian, everything ready to go?
And more.
Okay. All right. Well, here we go. I hope. All right. So with that whole idea, increasing efficiencies in agronomy is really what we're about today as we start to look at what SummitGold does providing products to you. I always start the presentation with this idea of what agronomy is. I'm an agronomist and I work all over the country. And oftentimes people get excited about talking to an agronomist. They bring in their soil test. They'll ask for a second opinion for no price. And I said, be careful what you get for information, because since you didn't pay for it, it might be worth exactly that. I don't typically recommend as much fertilizer to other people, especially if they've involved biology. But agronomy is not just soil testing. It's the study of plants and soils and how they interact to optimize production. It's not one or the other, it's both. I think many people understand that the soil is designed to feed the plant. That's why we've spent so many years talking to agronomists and fertilizer companies. The mineral elements that are in the soil, whether they're there by nature or whether we put them there, we understand that plants are actually going to pick those things up out of that system. What most people have never been told, however, is the plant is designed to feed the soil in return. The soil cannot feed itself. It cannot find food sources unless something actually physically falls down on top of it, like you think about animals or even plant material, that type of thing. But without that material in the soil, if the soil is barren and has no plant in it, the soil cannot get fed. And so over time, it begins to go dormant, and after a number of years, appears totally dead. And so until you actually get plants back in there, a carbon source to grow again with some moisture, that soil is not going to be functioning. And I think if you understand this situation, that plants feed soils to actually feed microbes, they make sugars, they push them out, they push them into the soil as well as amino acids. And once they do that, they feed the microbes. Microbes then in turn release acids and enzymes and melt the very elements that your plant's looking for out of old fertilizer and actual minerals in the soil. And that's what feeds the plant. So as the plant gets the minerals, it grows bigger, harvests more sunlight, makes a bigger root mass, and then that plant continues to put more and more carbon into the soil. As the prairies developed many, many years ago, those grasses grew every single year. The buffalo came and ate them, whatever they didn't eat, the product fell back down to the ground, and the organic matter continued to build and build and build. And every year those prairie grasses regrew, put in bigger root masses, and 60% of your organic matter comes from your root masses, not your tops. So that's how prairies became so rich in organic matter. And of course, as far north as you guys are, you have a shortened summer and a longer winter. And so the cooler soils kept organic matter building, and voila, you have a system that creates that. If you understand that they're supposed to work together all the time to replenish each other's needs, you'll start to answer questions that you may have had in different years about, why things happened the way they did. I mean, one of the most common questions I get is, why in a year when we get 5 or 6 inches right there at pollination, do we not get top yields? And oftentimes the easy answer is you store all of your nutrients and your sugars and all the things that the plant's been making to go ahead and fill those kernels on a corn plant in those roots. And if you get 6 inches of rain and you completely suffocate the soil for more than 48 hours, those roots die. And when the roots died, so did all the stuff that you stored in there, went with them. And as a result, now you don't have the yield you're expecting to have. So when Chicago says rain makes grain, somebody needs to quantify exactly when that rain came and how much it was, because just because we had 10 inches, if 6 of it came at the wrong time, that is not going to work for us. All right, so when we look at the soil, it's a fairly complicated situation, but it can be fairly simplified down to this. There's a physical side, a chemical side, and a biological side to soils, and those properties are all independent. We look at the physical conditions, how tilthy the soil is. If we have to use tillage and how we aerate those soils, that would be the physical side, along with the sand, silt, and clay and organic matter. The chemical side being that which is interacted upon with the chemistry, the nutrients that are on a soil test, what kind of chemicals we're actually putting in it, how the chemicals release and that thing. Biological side is going to be the pieces associated somewhat with organic matter, but also in the actual living life that's in that soil. And so when you impact one in a major way, you automatically impact the other two. And soil biology needs proper physical and chemical conditions to operate efficiently and properly. As an example, for instance, if you are aware that 90% of phosphate that gets into your plants comes through biology. Biology is responsible for keeping phosphorus releasing in that soil. If you decide that you want to go over the top of the soil with a tractor that's pretty heavy and the conditions are kind of wet, obviously you're going to go over there with that weight. You're going to compact the soil. When you compact the soil, you push out air. When you push out air, you slow down biology. When you slow down biology, phosphate doesn't release. So over time, as that soil is actually being influenced like this, your soil test level of phosphorus will fall if there's no air and you're compacted. So what do? In order to farm that farm, if you want the numbers to come back up, you go buy fertilizer. Over time, if you buy lots and lots of fertilizer, that's salted fertilizer, and you start raising the salt condition of that soil with lots of fertilizer, you will, in a sense, because salt destroys cells, slow down biology. If you slow down biology, then your physical condition, which is coming from, let's say, soil tilth, and biology is what's responsible for making, if you will, soil grease or little pieces or liquids of things that actually aggregate the soil together and make it nice and happy and healthy. If the biology can't function, then your physical condition falls off. And so to fix the physical condition, you till. So it doesn't make any kind of judgment as to what's right, wrong, or indifferent, how you choose to farm. It just says if you understand how these things link together, it's no surprise that in some cases, the more fertilizer we use, the more tillage we often use. And if we till too much, we end up buying more fertilizer. So, it's kind of a give and take. And for those of you who, recognize that biology reigns king, they're like, well, if we just no-till, then we don't have any issues. That seems kind of screwy because biology won't impact the soil, and that's not true. You'll see biology shifts oftentimes make the soils harder initially, but they do require huge amounts of chemical nutrition to survive in their little homes and colonies. And so oftentimes in the middle of a summer, when you get maybe 5 or 6 or 7 days right in the middle of grain fill and corn, for instance, and it's a little too dry, and you would say, well, my no-till is going to be fine. And all of a sudden you go out there and right in the middle of that dry weather, you lose an inch or two of kernels, and you say, well, that doesn't make sense. We shouldn't be losing kernels because we're not that much lower in water. But those microbes demand huge amounts of huge amounts of nitrogen to eat the stuff around them in the soil and make their little colonies. And so they all of a sudden deplete nitrogen in the soil to make carbon. And you suffered a little bit of a loss. And so oftentimes just lightly scratching the soil every once in a while, every few years, and we're not talking about turning it upside down with a plow or going in there and ripping the living daylights out of it 6 to 10 inches deep with a field cultivator or a chisel plow. Just something as light as even an aeration on the surface or a Danish tine harrow can release huge amounts of nutrition and buy you big yields. We've had people in the past that have done that when we suggested back in 2008 when phosphate went to $1,600 a ton, or when the price of corn went in the toilet here a year or two ago, and people were trying to figure out ways to save. We created starter programs to work with them and told them just go out and scratch the surface 1 or 2 inches deep and plant the corn and put a little nitrogen in there too. And lo and behold, where some of the guys did that, they picked up corn that, even though those years were pretty good on yields in the 200s in a lot of areas, they were almost 300 without lots of inputs. Now, the scary part of that is like, well, if it works that well, and I've been no-tilling that long, and that's how I release fertility, maybe I should be going back to tillage. And that's the real trick. It's like, oh, you could do that for 1 more year after that and still probably get some very good results. But after that 2nd year, you better be back to letting that soil rest. It's no different than tearing out, a pasture or something that's been a pasture for a number of years. If you put corn in it the 1st year, oftentimes it's the better crop. And sometimes the 2nd year is the best crop. But then after the 3rd year, you realize that the yields are starting to go the other direction because the biology and the nutrition is changing. So soil properties are interdependent, and you're looking for basically the nice little center spot there where the plant is. That's where your best soil tilth in a balance of good biology, physical conditions, and chemical conditions reside. So soil tests. Interpretations, because soil tests are a relative thing. Unfortunately, I think once we see those things on that soil test, if we got really good numbers, we're ready to go ahead and put that soil test behind glass and hang it on the wall and be proud and all kinds of things like that. Oftentimes, when you take a soil test, if it's been hot and dry for a long time, the soil test levels are much, much lower than they really should be. Once they get warm and wet, you'll see the numbers go up dramatically just from the fact that biology cranks up. So soil tests should be actually looked at as helping you understand, are you balanced or are you away from balance? Are you moving far away? Or are you coming back closer to a soil balance and nutrition? And I realize that's kind of vague right now. We'll talk a little bit about that. But there is a balance that you get with nutrition, and the closer you get to balance and try to manage the balance, the better you'll be. Numbers on a soil test don't necessarily determine anything to do with yield. If that was the case, then how could a soil test that was a good biologically developed soil that had 6 to 12 parts per million of phosphate yield the same or better than a soil test that had 75 to 150? That happens a lot. People don't talk about it because they don't understand it, but it does happen a lot. When those soil tests were actually invented, the only reason they were invented was the government asked the land grant institutions after World War II, when they had so many munitions left. They said, you develop us a test that will give us an indication of what the soil available nutrition looks like to help a farmer realize whether or not he's likely to get an economic response, a positive economic response to fertilizer application. If he has numbers that are low and he thinks he can get an application to pay him, he can buy these munitions and everybody will be treated fair, and we're not going to dump all this stuff in a hole or out in the ocean and waste it and screw up, the ecology. The balance of nutrients is just as important, if not more so, than the quantity. All right. I have had people, and this is not something I recommend, but I've had people that have shown me soil tests that have been as low as 2 and 3 parts per million of phosphate, 60 to 70 pounds of potash showing up on there, good levels of calcium, magnesium, and no major sodium, and a balance of micronutrient nutrition. They found this out in some cases after buying a farm. They took them over and it was too late in the season to fix them. So they would go out and put an on-seed starter on the plants, on the row, put a little micronutrients in there, put in some biology, put on 150 pounds of nitrogen to just try to grow their baseline crop, and end up growing way more than 200 bushel corn. So the numbers are deceiving. He grew 232 bushels in that field. He had perfect weather for the year, but he had a balance. A few years later, he went back in there and he fixed that soil, he told me. He put in 300 pounds of phosphate, 300 pounds of potassium, 250 units of nitrogen. And the year that he did that with decent weather, he grew 125. And I said, well, you fixed it, didn't you? He says, yeah, I sure fixed it all right. So understanding how to do some of these things in a translation, base saturation levels are not something you're probably used to listening to. You're probably listening to just raw pounds or parts per million. So in some cases, Brian can have some intervention with you there on that. But the whole idea of understanding that a certain percentage of the exchange sites in your soil should have calcium, somewhere around 70%. They should have some magnesium in those soils in your area, probably somewhere in the vicinity of 10 to 15% maximum, about 3 to 5% on potash, and maybe a little sodium, and then a few micronutrients. Any micronutrient can be a limiting factor. Any macronutrient could be a limiting factor. I think you've probably seen that information before that shows you the stave in the barrel idea. But we often look to the macronutrients in the staves. We don't think about the micronutrients as the staves in the barrel. And more than probably 30% of our customers, as we've looked at them in the last few years, and the soil tests that they give us, are showing major micronutrient deficiencies in comparison to the level of macronutrient deficiencies. If you think about the levels being way apart, if we have macronutrients up at the top and micronutrients below, if we bring that balance closer together, we actually get higher yield potential, even if we stop putting on macronutrients or put money into micronutrients. That happens. And our objective long term is, if we want to bring that up, the next time we start putting in nutrition, we bring them all up higher. We don't continue to separate them apart, and we don't try to force them completely together. It's a matter of balance and moving that all the way through. Here's a picture of actually what I was speaking about before, optimum balance of cations. And cation is just a chemical term for positively charged elements when they're in their native state. Calcium is a 2+ charge. That makes it a cation. Magnesium is a 2+ charge. That's a cation. Potassium is a 1+ charge. Sodium is a 1+ charge. Even ammonium, from anhydrous ammonia, if you put it in the soil, it gathers hydrogen from water. It changes to ammonium, NH4. It becomes a 1+ charge. The trace elements like manganese, copper, zinc, and iron, those are all 2+. And then acid, hydrogen, is just a H+. So all of those actually stick to your soil because the soil has a negative charge, a net negative charge to it. Now, if you have all these elements that we're talking about here in a proper balance with the numbers that I've showed you here on the right side of the report, and many of you by nature, because you're in the Dakotas, there in the plains, you might have soils that show you 5, 6, 7, 8% potassium. We've seen in some cases as high as 10. And that's exciting to know you've got that much, but that's actually a little bit high. But then also in your soils, because you have lots of clay, some of that is not real available. When you send that soil sample in, they crush it, they churn it up, they release all the potassium, and some of your potassium in your soils is not really available. So there are tests to be able to delineate those out, and the plains is the most common place for them. So I don't necessarily get too disjointed when I see high potash levels up there, because I know that they're not all actually a part of the entire available portion. But you'll see all of these numbers, if you balance them out, your pH would be 6.3, and that's leaving some acid in the system. I never take acid completely out of soil, because if acid is there, it melts the zinc and the iron and the manganese and the copper, those metals. When you pour acid on a metal, you melt it. So if you could get your soils to have acid showing up in them, which is difficult, I realize, up there, and you balance them out, your pH would be 6.3. What we often help people do as we consult with them is realize if they do have high pHs above 7, which is alkaline conditions, oftentimes we will use acid-forming fertilizers in the bands that you can use with the planter, or even spray it over the top, like ammonium thiosulfate, for instance. And that acid will react with some of that and release some of these nutrients for you. So there's a lot of different ways that we've used over the years to help people manage the soil, rather than trying to take on every single square inch of soil a foot or 2 feet deep and make it perfect. We develop systems to allow ourselves to be able to manage that. If you look at the top of the page, you see it says for nutrient sufficiency. We always assume that since we have these balances, it's all about just the nutrients for the plant. And sadly, that's not true. The amount of calcium and magnesium, potassium and sodium on those exchange sites is actually managing your available water. Calcium, of all these ions, calcium is probably the biggest. And if you think of a round ion about the size of, let's say, a basketball, calcium's a big ion, and it keeps a shell of water around it. It's a very thin shell of water, and it holds it loosely. So you'll get shrink and swell on your clay particles. But because it holds it loosely, biology and roots can extract that water easily from the calcium ion. So having good high levels of calcium manages your air water very successfully. If, however, God bless the Canadians, they gave us all their magnesiums from whatever mountains were up there years ago when the glaciers came through. They dropped all the magnesium down here in the northern United States. And that magnesium, if you think, I said before, of basketball for calcium, magnesium would be the size of a large softball in comparison. And it has a same 2+ charge, but that density of that charge in that smaller molecule holds a great big fat shell of water, almost as big or bigger than it is around it, and it won't let it go. It holds it tightly. So high magnesium soils tend to be a little bit wet, but they're drouthy at the same time. You go out in the middle of summer and you kick around with your toes, and you're like, well, man, into my boot, I see almost some mud out here. So I should feel good about it, but man, the crop is looking drouthy. Well, that's because magnesium is starting to rain and it's out of balance. There's way too much, and it makes it sticky and wet the minute it gets wet, and it makes it sticky and drouthy when it's dry. So managing a lot of this stuff is, I realize it sounds complicated, but the point of it is, if you do things chemically correct for that soil, you'll create a better biological environment, because if you have all that magnesium, you've got tight soils and you don't have as much air. If you can get the magnesium to kind of settle down, put a little sulfate out there and settle it down, you'll manage water and manage ecology better. What plants really need to grow? Well, plants themselves are a sugar machine. They're harvesting sunlight and they're turning sunlight. You guys familiar with photosynthesis? It's carbon dioxide plus water in the pleasant presence of leaves with chlorophyll yields glucose sugar and releases oxygen. So plants are sugar machines and they need nutrients, but as you see here in this picture, they don't need as many nutrients as they do total carbon. Sugar is made from carbon as a backbone, carbon and hydrogen and oxygen. And so these are energy conversion machines and are very, very dependent on making their own energy and some of the nutrients that they extract from the environment, especially carbon dioxide and water, to be able to run that energy machine. It's all about sugar. Plants are designed to run on sugar. They spend 96% of their time in their lifetime making sugar. They make sugar to grow. They make sugar to feed the soil. They make sugar to reproduce. They make sugar to fight stress and pests. They only know how to make sugar. It's their only purpose in life. We go back to this scenario about all this sugar and the importance. Many of you guys are into the precision management and some of the new technologies that are out there to manage that. One of the things that's being provided more and more often is pictures of crops under stress. Sugar is what the plant uses to fight stress. If you have high intensity sunlight and heat and drought, the only way a plant can fight off the drought is to burn its own sugars. When it burns its own sugars, it starts to reflect light in the infrared spectrum entirely differently. So when the government sends out pictures of stressed crops and you see some grays and some reds and different colors, when the areas that are stressed change color, insects see color with their eyes. They don't see the same way we do. So they're able to pick out all the subtle differences that they can see as they fly over the top of your crop. They pick out the colorations. So they're seeing exactly what the map sees. And when they find the areas in your field that are low in sugars, they fly immediately to them, lay their eggs, or start attacking those crops. Nature takes out the weakest first. And I think a lot of people have tripped over this through the years. They've heard it, but they've never exactly seen it, and they don't understand why. And it's just simply that. As insects look at your crop, they're looking to see if it's low in sugar. Insects can't handle sugar. Sugar kills or repels most insects. So the higher sugar content your plant makes, you can keep insects at bay much, much longer. So if they fly over your field and your field's all one color and it's high in sugar, they're going to your neighbor. So all you got to do is figure out a way to keep the sugars up, and you can let your neighbor spend the money on the insecticide. But these plants function with water, but they will be more efficient on less water when they make more total bricks or density of sugar inside their cells. And I've told people for decades, plants that are high in sugar need far less water to finish their cycle. And in some cases, maybe you've seen, if you've driven by in some places where Brian's had some crops for some years, with his rotations and some of the programs that he's used, oftentimes they're higher in sugar for longer. And you might say, wow, the crop over at Brian's doesn't look like it's stressing like some of the others are in the community. And that's part of the reason why. Is fertilizer food? We trip over this. And sadly, we call oftentimes the fertilizer industry a plant food industry. We should not think of fertilizer as food. Think of fertilizer as nutrients or vitamin supplements. I take a vitamin supplement every morning. I take a little pill, it's about this size. You look at me and the size of my body, I weigh somewhere between 215 and 220. if you think about 300 or 400 or 500 pounds of fertilizer spread over the top of 2 million pounds of soil, which is an acre furrow slice, they're more like nutrients. You don't ever by accident wake up in the morning in a stupor, take the lid off your vitamin supplements, and make the mistake of thinking that they're food. It doesn't work that way. So food is food. Crop food comes in forms like carbon from carbon dioxide or breaking down organic matter, humic acid, things like that. Sugars, amino acids, which are basically just sugars with nitrogens married on them. And then when you train amino acids together in a big complex, we call those proteins. And even when you put proteins together in big long trains and chains, we call those enzymes. The point that I'm trying to make is crops need a sufficient level of fertility and nutrients. We understand that. But though they don't need excessive levels of nutrients, but they need lots more food. Now you can say, well, I thought a plant was supposed to make its own food. And it does. But the microbes that are in the soil need more food to operate more efficiently and to build higher populations so that they can release more nutrients out of the soil naturally for that plant. We oftentimes get caught up in looking at tissue analysis. And this picture is designed to help you understand this, that at some point, tissue analysis gets us a big part of the picture. But oftentimes we're trying to do something that's not actually physically possible by the plant. I've asked people, if you could get your phosphate levels in your crop up to 4 or 5%, and you thought you could get it to 6 or 7 or 8, if you got them there, would they yield more? And oftentimes people say, sure, if I could get the levels of N, P, and K up higher in my tissue, they would always yield more. And that's not true. If you're familiar with something very near and dear to our heart, we've always talked about in the world of chemistry, the dose determines the poison. And so if we were to take Brian and Nick's little office there and completely shut you off tight and seal off all the windows and the doors and pump pure oxygen in there, for a short period of time, it would become a hyperbaric oxygen chamber and you'd feel really good. But if we left you in there for 24 hours, how many of you would still be alive tomorrow? And the answer is not too many of you. You'd all be dead because you'd have toxicity of oxygen in your blood and it would kill you. And we do this a lot of times with plants. We purposefully go out there when we see a low tissue level and try to put on too much to fix it. And we only put on one nutrient. And oftentimes the reason some nutrients don't show up on a tissue analysis isn't because that they're not in the soil, but something else in the rest of the tissue is inhibiting them from being used properly and is keeping them from being maximized. And so oftentimes it may be something like low boron. Low boron makes less sugars. That means less sugars are trying to flow around in the plant. So oftentimes the plant tries to compensate by putting more water in there, but it doesn't have enough potash, or it might have too much potash. All kinds of things connect to each other, and we don't really help people understand that because they say, well, that's just too confusing. But the point is, you need enough to get you up through the deficiency and marginal zones into an adequate zone. And if you go over with any one or two major nutrients, you'll fall over the other side and at some point get toxic. So that adequate zone that's there at the top of that picture means that all nutrients are working in conjunction with each other at a higher level. And if you want to bring them up, you almost need to bring them up in relationship with each other. So if you want to foliar feed, you foliar feed with something that has a pretty good analysis of N, P, and K and has micronutrients to come along with it. And that's where you're going to find the Randy Dowdys and the David Hulas of the world. Not only are they enriching their soils with a little fertilizer, lots more food, many more microbes, but when they're foliar feeding with lots of food and total management packages for nutrients in a combination. So the nutrient concentration in the plant needs to be as balanced as it can possibly be. We see this oftentimes with potash. This data now comes from clear back in the late 80s, early 90s, and I've used it all my life. I actually was approached by Don Huber to be his grad student And if I had been his grad student, this would have been my master's thesis at the time. But what they figured out was people who were trying to over-fertilize, this was out at the agronomy farm. There was a fight between the agronomist, the state agronomist at the time, on the response of hybrids to potassium. They had a lot of racehorse corns, and the racehorse corns were falling over. The state agronomist said, they're falling over because we have too much disease. The only way to get the disease to come down on these plants is to put more potash in them. So he said, let's put potash out there like crazy. Don Huber and Charles Tye said, no, that's reverse psychology for the plant. The plant is not built to handle that. The corn plant is not built to handle that. If you do that, you will upset the apple cart and they will yield less. So a fight ensued. As a result of the fight, Charles Tye and Don Huber built this research program and research idea to show them what was happening. So basically, at the agronomy farm, they said our soil test levels are only 2% base saturation. If we got them closer to 4, our plants would do better. They would stand better. That's what Dave was saying, Dave Mingle. So what they did is they said, well, to do that would take 275 pounds of potash, Dave. So we'll go out here and put 275 pounds of potash on that soil. They did it in the fall, and they did it once in the winter and once in the spring in different places where they could prove that at any point, if you put it on before the crop starts growing, you're going to have this trouble. So as you see before you, the red lines that you see are when 275 pounds of potash is put on any time prior to growing a young corn crop. And the blue lines are the same exact amount of fertilizer that was applied to the soil to try and achieve the same goal after the plant was at 8 true leaves. Because by 8 true leaves, without question, the ear of a corn plant is completely set. So if you put it on before you actually set the ear, you shrink the ear down because too much potash keeps ammonium nitrogen from entering the plant, and ammonium nitrogen is what sets your ear. So you have a nitrogen deficiency from the standpoint of reproduction when the corn plant is 3 or 4 leaves tall, because by V5, it's completely done. So it's not the potash that's the bad guy, it's the timing of the potash that's the bad guy. And so often what we're trying to do in our business is feed the corn crop and let the beans have the rest in a corn soybean rotation, which is actually bass-ackwards. We should feed the soybeans because the soybeans do not show that same type of response, and let the corn have the rest, and it would actually do us a better job. The same thing with nitrogen. Trying to put enough nitrogen on upfront one time for a whole crop just upsets the apple cart, especially for racehorse corns. Let me back up briefly to that picture where I just showed you. Most of the corns, when you start seeing there in the middle, 16, 17, 18, 21, all those corns in this hybrid response were racehorse corns. We move now to nitrogen, the same thing with racehorse corns, which most of your genetically modified organisms are today. They are racehorse corns. This is where they put on 120 pounds of just stabilized ammonia pre-plant, compared to 60 pounds as 28% through the planter and 60 pounds as stabilized ammonia. Every hybrid in there showed a positive response. As you see, those which had 14 and above for the statistics in that particular situation was a statistically significant situation.
Downing that big ball under your ass.
Somebody asking me a question? Okay, thought I heard a question coming in there.
Well,
so the point
going on there.
What's that?
It's not us.
Not us.
Okay, all right. Maybe somebody's got a radio on out here. So anyway, the point being, if you split up your nitrogen, your racehorse corns need nitrogen later in the season, and they need it as an ammonium form. So this allows people to see, it's like, wow, I need so much up front to set the ear, but if I can deliver it late in the season on a racehorse corn, I get more and more bushels. And so these are significant increases. That's why, and this is Charles Tye and Don Huber were people who worked with Dow for many years, helping them understand how to use nitropyrin or Inserve. So InServ was developed to go out there and treat corns that were knee high or later with nitrogen stabilizers to keep the anhydrous in the ammonium form. And lo and behold, the longer it lasts, the better the response. We go to phosphorus, some interesting things happen. Phosphorus as an orthophosphate form, this form that's in some of these good high quality starters, not necessarily 1034O. That whole situation we studied back as early as 1989. You can see what this picture shows is the higher the level of the phosphate is when the plants are very small. Down at the bottom, you see the phosphorus level in the tissue before and after 6 leaf tips. Well, 6 leaf tips, and this was done in Canada at the University of Guelph. 6 leaf tips in Canada is like 3 leaves in the US. So it's like the currency. Everything with a currency is screwed up, and so is their science. But the point being, before and after 3 true leaves, that's what this whole study is about. So in the first one here, you see they had lots of phosphate in that plant before 3 true leaves, and at 3 true leaves, they made sure the phosphate maintained, and lo and behold, they got the maximum number of kernels. They went to the next part of the test where they kept the tissue and phosphate down in the intermediate level before 3 true leaves, and then foliar feed it immediately at 3 true leaves and bring the levels of phosphate up. Lo and behold, they lost kernels. You make one more step, you go to a low level of phosphate very early, and then at 3 leaves, return it very, very high. Lo and behold, lost some more kernels. So, story is, your plant needs phosphate and lots of it before 3 true leaves. That's why on-seed starters work in the first place. This is what allows us to develop the maximum total of rows around, because it takes lots and lots of energy to do that. So here's a picture of a corn plant. The goal is a larger, more consistent ear on every single ear or every single plant. The hard part about understanding some of stand optimization, early growth, uniformity, if everything has the nutrients it needs, if everything is coming up at the same time and everything is growing uniformly, we've all had fields like that, and we expect high things from those fields if everything goes good with the pollination, the nicket pollination. So that's what we're searching for in this whole thing. So by putting everything for N, P, and K to develop ear size, along with micronutrients, along with the microbes in complement that actually release phosphate and so many of the other nutrients in this system, as well as micronutrients, because the plant is actually sending out signals to those microbes and saying, hey, I need some manganese. Is there somebody out there with a enzyme or an acid that can melt me manganese out of minerals? And a little pseudomonas organism out there says, yeah, hey, I'll do that. You ship me some sugars, I'll give you some manganese. And so they do. They interact with each other. You've all seen that same type of thing with a soybean plant with nodules. Microbes talk to microbes, plants talk to microbes in the soil. Microbes talk back. The plant goes to those microbes, allows an infection. Everything happens. The same type of infections happen with all other microbes. We just don't get to see them because they don't make nodules on the roots. But that seed, gentlemen, is designed to germinate, send out a radical and a seminal root, start growing that plant up through the soil, and take that plant through 5 true leaves. Now, if you heard a while ago, I said by V3, it's already set the rows around. By V5, the whole length has already been determined. And that seed root is designed to take that plant through 5 true leaves, and then the brace roots take over and are starting to build the bigger infrastructure of that plant and take it through the rest of the year. So anything you want to do to have an influence on yield in the early part of the season has to be done on these seeds early. We bring up the base saturations of calcium up high to manage water and give us a good environment. We band a little 28% along with some sulfur off to the side in a 2x2 band if we can. And the reason we do that is very important. Charles Ty and Don Huber helped people understand that there is a protein in the plant at this very young stage called zein, Z-E-I-N, zein protein. That zein protein is responsible for turning on every single kernel that's formed. If it is not deposited, that protein in a kernel, it can try and pollinate, but it will never fill. It will never turn on. So those of you guys who might be growing corn and seeing a nice, fluffy, soft tip on the end of an ear, every ear in the row, that's a sulfur deficiency when the corn plant is this tall, just 1 or 2 leaves. We look at the starters on the corn. We set these things up purposefully to give us a good stand, uniformity of stand. If you've listened to Randy Dowdy, Randy will tell you if you get more than 12 hours difference in germination in a 12, 24, 36-hour period, you're losing 20 bushels in every delay of 12 hours between those. If they all come up at one time, that's when he fertilizes for 500 bushels of corn. But if he has 3 separate times and intervals in a 24-hour period that they're not all up and not together, he never fertilizes for much more over 200 bushels again. So it's a very interesting thing. So we use starter on corn to actually set the yield potential on these crops. And we have these same starter programs across the country that give us ears that are achieving 300 bushels if everything else goes right with that system. Very rarely do you get 300 bushels, but we have people who do all the time, and the ears are all similar in size. So those seed roots and early development on those plants is extremely important. Corn and all plants have 10 times more sites on their roots to absorb primary orthophosphate than anything else. I often say, why do we look at nature and fight this thing? Polyphosphate is chain after chain after chain of phosphate molecules bound together that must be broken apart by biology and heat. And it takes, in some cases, weeks to months to make that happen. So if we have starters with lots of polyphosphate in them, all we're doing is building soil test levels into the field. Now, we do that because we feel better if our levels are higher, but if the plant can't utilize them, and especially if it's in a starter, why are we using them in the first place? That's the question. Most of the products that you're looking at are 725.5 is an 80% orthophosphate. I called up one of the premier polyphosphate producers, 1034.0 producers in the country, got right up to the top, and I said, hey, you guys really make a high quality starter, or not a starter, a high quality 1034.0. What do you guarantee your orthophosphate content to be? Oh, he says, that's good. We have one of the best. We're at 30%. Oh, that's great. Fantastic. That is good news. Great. Thank you for answering that question. I didn't say anything about it. I said, that's fine for somebody that needs phosphate and wants to build levels, but it doesn't do anything for corn plants because 70% of that material is polyphosphate, and it's not doing you any good until the middle or latter part of the summer, if it's ever going to do any good at all. And if your biology is working in a warm, wet soil, it's releasing all your phosphorus out of the soil as, get this, primary orthophosphate. It's all about efficiency, and that's why we keep talking about these things. The efficiency and composition of fertilizer is more important than the total quantity applied. If you pull a soil test out of the side ditch, or you've ever farmed a fence row, pulled a fence row out between 2 fields, and you pull it out, you're going to find there's 6 to 12 pounds of phosphorus in that soil. You'd say it's not possible to make the plants that grow over that fence row, but it does it all the time because there's 6 to 12 pounds every moment of every single day. It is the ultimate spoon feed for that system. You have tools to increase fertilizer efficiency now at your beck and call. As science has brought more and more good quality products in availability and form, you get to use them. You can target them to timing. So like when we talked about with the corn plant, why are you putting on tons and tons of total fertilizer to try to finish the deal when fertilizer in the right quantities up early sets your yield, and then you can do other things throughout the season to finish it. So you can target it on certain places and at certain times. That allows you to be more efficient with your fertilizer. I'm thinking that most of you have been told the way to fertilize and farm properly, one of 2 things from the economics and the agronomy departments. save yourself into prosperity and hope the good Lord's good to you with weather, or spend yourself into prosperity, run the top completely out of this thing, and you'll top out every single time. That's not been my experience in 30 plus years of agronomics and being in my entire life on the farm. That's not been my experience. But they never tell you that if you can use less, if you understand when to put it on, how to put it on, in the right form, the plant doesn't care where it finds its fertilizer, its nutrition, as long as it finds it. And that's the point. You can use microbes and biodiversity. The fence row, the reason it does what it does is there are multiple types of different microbes in there, but they are in there by the hundreds of billions in every square foot, hundreds of billions. And so what we do is go in there and extract out some of those microbes, brew them up into products that give us numbers that are upwards of the hundreds of millions in 20 drops of water, take them out, put them into a fertilizer situation that's a starter, and we move the fence row back to the farm row. We put in orthophosphate because the plant tells us that's what it wants, that's what it needs. We put in micronutrients and we put in microbes to take that whole idea of the fence row and put it over a few feet back into the farm row where it belongs. We put carbon in terms of sugars, different types of amino acids, sometimes some enzymes, crop food. And so we put food in there for the microbes and food in there for the young developing crop. You don't think about it, but if corn is actually programming its yield when it's 3 leaves tall, whenever a plant is moving from vegetative growth to reproductive growth, it needs lots of energy. And we think corn moving from reproductive growth, that's pollination. So really there are 2 times in the life of that corn plant that it needs extra energy. One is when it sets the ear. The other is when it pollinates and starts filling the ear. So as we started putting in nutrients and energy up front, lo and behold, the ear size started to grow. So it should make sense. If we actually look what kind of things happen, this is fascinating because so oftentimes when we do things in agriculture, we're always trying to tell corn growers, it was done on something else like pine trees. Here's a good example when it wasn't. It was actually done on corn. The effect of inoculation with mycorrhiza, and this works very simply with mycorrhiza and also bacteria. So good guy microbes being stuff we look at under a microscope. So fungus, bacteria, actinomycetes, these mycorrhiza, they're all under a microscope. And so this whole process is adding in biology with and without added phosphorus and looking at what happens to the content of the elements in the shoots of corn when we do this. So the numbers that you have in front of you basically are saying all the nutrients are listed on the left-hand side. In this particular study, they were looking at phosphorus, potash, calcium, magnesium, zinc, copper, manganese, and iron. That's what those represent. So they had pot studies set up where they did not put any phosphorus into the pots. This is naturally occurring soil. It's not a potting mix. This is naturally occurring soil. So they basically sterilized that soil in an oven to kill off the biology, added no phosphorus, and so microbes were working in there before they sterilized it. So then they actually start growing the plants, the corn plants, in sterilized soil with no biology and no added phosphorus. And as long as roots are growing in a soil, microbes have released things before, but they find the nutrients in the soil anyway. There are some always left there. It's not totally void in an agricultural soil. So they started to grow, and you see the numbers that are listed. So then in the next pots, they water in the biology and put it down into the soil system, and the plants that grow in there, you can see the numbers start jumping up fairly significantly. Third more, doubling, some cases, much, much more. Then they compare the difference to putting in 25 milligrams per kilogram, which is 25 parts per million. And if that was on a soil test, that would be the equivalent of 50 pounds to the acre. So they put just a little phosphorus in a sterilized soil, and lo and behold, that phosphorus being in the orthophosphate form, look what happens. The roots pick it up, the roots get bigger, they dig around farther, and the numbers jump up significantly again. But look what happens when you provide orthophosphate for all those 10 times more sites and bring biology to bear on it. This is biological farming. This is the same thing that organic farmers would do, but they're not using lots of synthetic fertilizer and lots of pesticides. You can use whatever you want. Whenever you bring biology in here, these are the kind of numbers that you generate. And so if you're growing animals on a farm and producing grain, you can see fertilizer does a fairly decent job of improving your nutrients. But fertilizer and biology does a huge difference. You would never change bushels for bushels off of this farm with someone else who's not including biology in it. And this is why in many cases forages are changing quality and quantity. Grain quality is changing in quantity and quality. If you're producing this stuff and growing it on your farm, you should never let it leave the farm if you have animals. If you're in vegetable production, those of you guys who are talking about vegetables and organic production, those numbers, you're expecting to do better on these. Why do people want your organic produce? Because the nutrition is much higher when you bring biology to bear on it. So if you put biology in there and biology releases phosphorus in the orthophosphate form, and you have lots of biology doing things to gather these other nutrients, it's no surprise that you have some of the highest quality produce that can be made. So in all these things, we learn to put in phosphorus with biology. Your targeted fertilizers, here's a list of them. 725-5 is a low salt, high orthophosphate starter. It provides increased phosphate availability as an orthophosphate form. 80% of it is orthophosphate. Early plant growth. And whenever you're putting that energy in there as orthophosphate, that's what primes the energy machine, and sugar production starts very high from the day those plants start to germinate. So your sugars are always higher, and your quality and your ability to fight off stress is higher. This is why people who have tried some things side by side in planters before, they'll put these orthophosphate products on one side, and on the other side do nothing, or in some cases use 1034-0. They might have, you know, a 12 and 12 on a 24-row planter. And then all of a sudden, after the corn comes up and puts on a leaf or two, the weather changes and you get a frost. And a frost comes across the field. And suddenly, within 24 to 48 hours, there's 24 rows of plants standing where the orthophosphate was, and 24 rows of frosted off corn where it wasn't. That's because that orthophosphate brings those sugars up, and sugar is not very easily frozen like water would be. And even though there's sugar in those other plants, the water concentration is much higher, and you freeze the leaves and die. So it's very important for cool planting conditions. So as you move on into the latter part of spring and early summer, if you're running late to plant, it's obviously not going to provide the same issues that it would on the early side. However, the later you plant, oftentimes you're interested in speeding up the life cycle of the plant, and more orthophosphate will cause that to happen. That's been known for 50 to 70 years. SG elements, the chelated micronutrients that we call balance. That's a dual type of chelation with different types of chelation done in there. And chelation just meaning claw, it's the Greek word for claw. That means you put an organic molecule around an element, and it's protected from interacting with chemistry like it would in like salt and water would in a test tube. They can't interact with each other, so they're not tying up with phosphate and some other things. That's a whole nother seminar. But those micronutrients are in there for increased availability and efficiency, and it provides a balanced blend of zinc, manganese, boron, copper, and iron in the plants that we're growing. They are balanced for those plants. SG Relief is an ethylene inhibitor. Many of you might have heard of Bioforge that's been out there for a number of years. The same man who invented Bioforge came up with the technology for SG Relief. It's much simpler. It's much less costly and can be used multiple times during the year. Whenever you put stress on a crop, crops develop ethylene. When they develop ethylene, it's a signal to themselves to stop growing. What do you use to make green tomatoes red and green bananas yellow to make them ripen? You spray them with ethylene. If you spray ethylene on a plant too early in the season, it stops making roots, it starts to shut down, it tries to finish its cycle, make a few seeds, and go home. You can make the plants not make ethylene, almost look oblivious to the stress, and go right on growing if you stop the ethylene from being produced. And that's what this product does. And it's a product that might cost $2, $2.50, $3, somewhere in that vicinity. The guys can tell you it's not expensive. And many people, every time they're going over that crop, are actually putting in a couple of dollars worth of this, because they never know exactly when the stress is going to come. Or if they do know that stress is coming, they like to put this on there to make sure that the stress is minimalized on those crops. Biological tools on the seed, corn and soybeans, and also in some cases, with the vegetables. Now the organic guys, as they said, the complement is not actually labeled in South Dakota. If you want to drive to Iowa or you want to drive to North Dakota and pick it up and bring it back, that's up to you. But as a general rule, we can't sell complement as the complement label until it's actually cleared in South Dakota. There's no dangers. Trust me, it works because it's in your SG Infuse, it's in your SG Assist. So for the guys that have done that, they've been using the technology and they're just stunned. They get much bigger root masses. They get much better earlier growth. And the sad part is that that we can't just necessarily bring it in there and drop it in there to you, because it is a wonderful product. Complement in of itself in all the other states is completely OMRI certified, but it is not cleared for use in South Dakota. So you've got those organisms in there, and in the SG Infuse, you're looking at a complete Infra product that develops a biological root zone, a healthy spot, has the micronutrients, enzymes that actually help release phosphate and other micronutrients in the soil, sugars and organic acids being things like humic acid and fulvic acid you've been hearing about in different ads and things that are out here, even vinegar, but there's no vinegar in this. This is mostly fulvic acid, which is a humic acid. Amino acids, which are sugars and nitrogens, and that's the oldest form of nitrogen feeding that goes on in the soil. That's what plants fed on for thousands of years. It's their most preferred form of nitrogen, and will actually feed them. So you're going to see lots and lots more things in the future that have amino acids in there for nitrogen. In the organisms, there are 30 plus unique strains of organisms that do all kinds of things, not just 1 or 2 or 6. There are 30 plus in here. Multiple seed and root protectants. You're looking at the products like SG Relief and some other things, some phosphite technology that's in here. So it is a complete type of product, and in conjunction with 725-5 gives you about anything and everything you need for the early life of those crops to set up the maximum yield. And basically you're going to finish out the rest of the season with side dress or late season nitrogen if you're in a corn situation. On soybeans, there are some other things that you can put in late foliar that can do some things and help you, but SG Infuse is the ultimate upfront complete product. SG Assist focuses more on sugars and organic acids, amino acids, and the biology. So here you're putting in a food source. If you think the nutrients are pretty good in your situation and you're not interested in buying lots of nutrients and keeping costs down, you can buy SG Assist and put in sugars and organic acids, help beef up the biology, get root masses to do the job for you, throw in a little nitrogen here from amino acids, put in the microbes, and see where you go. Crop food. Now, if we start looking at those food opportunities, you've got SG Fulvic, a high quality fulvic acid. Fulvic acids are true humic acids, but they are soluble at all pH ranges. Humic acid by itself is only soluble at pH 7 and above. So if you guys wanted to throw in something as a foliar food source and you threw in humic acid, if you drop the pH down below 7 by something you mixed in there quite by accident, not purposefully, or you didn't even know it, if that pH starts falling below 7, that humic acid gets gloppy and it starts falling out and settling out, and you've got a mess. Fulvic acid is also a humic acid, but it's soluble at all pH ranges. It's an amber color. It's a lot prettier. They're shorter chains. They're very effective on leaf surfaces and on roots, but you don't have the headaches with fulvic acid that you can get from time to time with humic. Now, if you're putting 28% or 1034O beside the row, humic acid is fantastic for roots. Fulvics are good for roots and great for foliar. Humics are outstanding for roots and poorer on foliar. So you can use these things, and as you have somebody who can help you with the information, you can do all of them. But please don't go throw humic acids into a blend that you're going to make up into a foliar if you don't know where the pH is going to end up. Always use a fulvic and you'll be plenty safe. Shift is carbon compounds with a foliar bioaccelerant. So you've got some sugars and maybe some fulvics in there with it. And then you bring in some biological stuff that works foliar. That whole realm is getting much, much more interesting. We're now finding out that when we put microbes on the surface of a leaf, microbes can talk through the surface of a leaf, conduct a signal down through the plant, and talk to their cousins in the soil to tell them and come protect the root system. It's fascinating. And some of the things we do, we'll put Bacillus amyloliquefaciens. Try practicing that 5 times and see if you can say it. Bacillus amyloliquefaciens. Spray it foliar on the leaf. It will talk to its cousin, Bacillus subtilis, in the root zone. And Bacillus subtilis will form around the roots and form a protective barrier. How can they prove that? Bacillus subtilis flashes when you use UV light, just like the yellow colors do on a t-shirt. When you go into a UV light and you take out all the colors except yellow, when you flash the soil with UV light, it reflects back all that Bacillus subtilis, and you can watch them move to actually protect the roots. Fascinating stuff. So you can also put in SG Infused and SG Assist, which we talked about before. You'll have carbon compounds in them. The neat thing about some of these technologies is the precision guys at the university are tickled to death. And sadly, like I said, if we could do some of the things with complement there directly, I think some of the guys in South Dakota would really enjoy this from the precision standpoint. Because you see some pictures here, the one on the left where you've got the SG Infuse in the row, not on the left, but on the right. In the middle picture, satellites from outer space. When you start using biology in there, the left side of that center pivot has biology in terms of organisms to use as biology in the soil, either for stubble digestion, which is a different product, or complement, which is the in-row starter stuff. And on the right side, so what that was the product put out there, and they're looking at the leaf area index, how much total plant mass is out there when we use biology. And as you can see, more consistently, far more on the left. In the upper right-hand corner of that picture, that's a gentleman who used 624.6. It could be 725.5. This is not from 725.5, but he actually used 624.6. 6 gallons across the entire field. And on the left side of that picture, where the line is obvious, all he did was put in 16 ounces of complement organisms in that. The biology sped that speed up so fast that crop finished pollinating 4 to 6 days before the other side ever even started shooting tassels. And as you can see down below, there was some significant increases. The guy had he posted 13 bushels, but in talking to him personally, he said, I didn't really want to get too carried away, but it was 25 to 30 bushels without question. The fun part about it, the reason the precision guys are looking at this is from Northwest Iowa last year. We have a booklet of about 30 to 50 pictures just like this. As bad as it was in parts of Iowa last year for heat and moisture, we still had people using the technologies, and precision agriculture is measuring the quality of starter and microbes. This one is a gentleman in Iowa who said he didn't really think that Iowa soils needed starter. Above the line where you see lots of the green is where he used starter with 725.5 and microbes. Below is where he ran out of starter. And as you can see, there's a 44.32 bushel per acre average. This is stuff that was up in the 253 bushel range, folks. So you were looking at somewhere in the low 200s as compared to somewhere around 250. That was an impressive number. If you're in the vegetable business, you should be excited. A lot of this stuff is very, very good for vegetables. Here in the picture of the potatoes, you're seeing a line down through the center of the field, and to the left, you're seeing a crop that's actually potatoes that's still flowering. On the right, you see very few flowers where the SG Infuse is. That's because it flowered 2 weeks prior, is already completely done and through flowering and making sacks of potatoes. On the left, it's behind. Ironically, on the left, it says untreated, but it's not untreated. It was actually treated with a compost tea. This was a known Rhizoctonia field, and as a result, Rhizoctonia was fed as well as anything else, and Rhizoctonia jumped on the roots. On the right side, we put the organisms that we know help exclude those types of organisms and keep them off of the roots. And lo and behold, the health was through the roof and the production was significant. 84 more 100-pound sacks. So that's 8,400 more pounds of potatoes per acre with that program. So this guy learned a lot about biologicals in one season. And what he learned was, if I use a general feeder on my fields where I know I have rhizoc, I made a big mistake. And here's what it looks like from above. When we sent the drone up, here's your picture. And on the right side, you see just left of the pivot lane, we had a few rows that were treated that way, and everything to the left was treated with basically a compost tea, which in some cases could be perfectly fine. But in this situation, it wasn't, because we know we had rhizoc in that field. And here you go. Here's the pictures. The pictures clearly show how the Rhizoctonia is attacking the roots on the untreated or the treated side with the compost tea. And on the right, you don't see you can see an occasional spot, but you don't see the roots, eat up with Rhizoctonia. As a result, the plants are making their sugars, moving them down successfully to the roots and in the tubers, and lo and behold, you've got a significant increase. What about a product called SG Accelerate? Accelerate is a group of microbes that actually focus on lignin and cellulose. They are specific to work on lignin and cellulose and help break them down. In our modern day GMO society, all those GMOs are bred to be higher in lignin and cellulose. They're bred to resist breaking down so that we get the production out of the corn. However, when we lay them down on the ground, they take forever to break down. The picture you see on the left is clear on the far left is the treated side. On the right of that area is the untreated side. It's very difficult to see this at 55 miles an hour. And people who don't get out and actually physically touch or walk over their stalks oftentimes say there is no difference. There is a difference. And when you treat them in the fall, if you can, obviously they can dig into the inside of these stalks and they work from the inside out. So they destroy all of the cellular integrity. They don't eat it up completely and make it go away. They eat out most of the energy that's in those cells, and the cells still kind of hold together. So in the middle picture, the one on the left is treated. They've been inside all winter. On the right is the untreated, and you can see what kind of condition they're still in. On the far right is a picture where Accelerate was actually dripping out of a sprayer. It wasn't being sprayed. It was dripping out onto the surface of the soil, and every foot or so you saw all these drops of where the drops fell down on the plants and started growing like crazy. So Accelerate is designed to accelerate the degradation of stalks and get rid of the problems that stalks can cause. Here's an interesting practical example of a way that Guy used this and was absolutely stunning, and is still being discussed in Iowa today, which is driving a lot of the sales of these particular products all over the country. This gentleman grew a 235 bushel crop in 2016. He used our products. He was tickled to death, the Accelerate products over the top of it. So this is corn following corn, and he got a 235 bushel crop. He feels like this is over 6,000 acres of corn now, gentlemen. So after that, he's like, I've grown the biggest crop I've ever grown. I'm totally out of nutrients. So he goes out and contracts for 5 tons of poultry manure to be spread across that entire 6,000 acres. Then he calls us and says, should I put on the Accelerate organisms? Because that's going to be another $10 or $11 an acre. I don't think I can afford that. It's going to have to be significant if I do that. I said, it's going to be significant. Trust me, you're putting out that much cellulose and lignin. This is going to be significant. Well, he says, I'll have to think about it. So we did. And he decided to go ahead and buy a tote of just straight organisms, and he put it on about 2,000 acres. So enter into 2017. He's got the corn planted. He's got the organisms over the top of the corn following corn and the manure. So spring was good. The organisms are incorporated, and now we're off to the races. He's got a pretty stand. Everything's going great. Then the second week of June, the water shuts off. And this is Pocahontas County. They got 0.3 of an inch, 3 to 4/10 documented across the entire county, and no more than that anywhere from the second week of June to the third day of August when the rain turned back on. The corn that you see in the upper left-hand corner is 5 tons of poultry manure under that scenario with no applied microbes. And you can see it was burning up, fired, and having all kinds of trouble. As they walked through those fields, they gathered the ears that you see on the right, and they estimated 95 to 125 bushels, which of course in Iowa is crop failure. Anything under 180 in Iowa is crop failure. However, the rep says, are these the treated fields? And the farmer's like, no. He says, I haven't gone to the treated fields. They're a couple, 3 miles away. He said, I'm so disgusted with what's going on out here. He says, I haven't even been in them. Well, he says, I think we should go look, don't you? He says, all right, let's go. So they pull up to the field, and as they pull into the entrance of the field, this is what they see in the lower left-hand corner. The crop is green to the ground. There's no apparent stress. It's fence line to fence line, end to end as they walk the fields, and they pull out the ears that you see here on the right side, and there is no evidence of firing anywhere in that field. Now, the yield that they're looking at here, the estimates early were 225 bushels. When it was all said and done, over the scales, the 4,000 acres of corn on the top, over the scales was 125 bushels on all those acres. The ones on the bottom were 235, just like the year before. Now, everybody and their brother was out in these fields. It was almost like a casino in the middle of Wisconsin. They were out in these fields trying to figure out what's going on. They had people from the universities out there trying to figure out what's going on. They were trying to figure out how they could pull the wool over the eyes and make these things happen. And I said, guys, this doesn't have anything to do with pulling the wool over eyes. This has everything to do with what we talked about a while ago. Let me see if that is the next picture. It's not. When I said photosynthesis is carbon dioxide plus water in the presence of leaves harvesting sunlight, the result of that is plants make sugar, glucose sugar, and release oxygen. Now, if you know anything at all about that equation or any equation, if you want to make more sugar on the right side of the equation, what do you have to put in? You have to put in either more carbon dioxide, more water, more sunlight to make it go higher. There was no change in sunlight on these fields. They were right against each other. So there was no monkeying with the sunlight. Water, documented everywhere, the water was the same, and there wasn't much water. So the only answer to this equation is carbon dioxide was being pumped out of these soils at an incredible rate. In 5 tons of poultry manure on a corn following corn field, there was somewhere in the vicinity of 8,000 pounds of organic carbon in the manure, plus how many thousand pounds of stalk material being broken down by microbial activity, pushing carbon dioxide up into the canopy. And these plants, if you've ever seen carbon dioxide research, and if you haven't, it's been done for decades. Go on Google, type it in, see if you can see some pictures. They always look exactly like this. Great big plants, great big leaves, incredible yields, and that's why we call it a greenhouse gas. The more carbon dioxide you put in the environment, the more it operates like a greenhouse, a controlled condition. And here's the evidence right in front of you. People were tripping over and trying to make it all to do with the nutrients. If it was the nutrients alone, those on the upper left-hand side would have done exactly the same. They weren't getting nutrients. Now you can imagine, like I said, plants that are higher in sugars need far less water to finish their cycles. Here you have the perfect example, but that's not the whole story. These plants did have less water, But if you can imagine what the size of these plants is above ground, where were the roots below the ground? Were they up in the top, or were they down deep in the profile? And the answer obviously is they were bigger roots deeper in the profile. And what do you find deeper in the profile? More water. So the explanation was very simple, and people were tripping over this explanation. If you put the accelerate on in the fall, you break down the structural integrity. This is a field from, I'm in Fort Wayne, Indiana, just east of me over the line into Ohio, where the guys put the accelerate on in the fall on corn fodder, and then came back in the spring. It was a cool, wet spring. They were going to have trouble planting, and they did where they didn't have the accelerate. It seemed to go much nicer where they had the accelerate. And when it was all said and done, the numbers in this field side by side to this line were an additional 25 bushels of soybeans on the left side where it was treated compared to the right. Now, in both the last example that I showed you on the corn with 110 more bushels, and in this case where you have 25 more bushel beans, the well-intentioned snake oil salesman goes out and says, see, I can make you 110 more bushels. See, I can make you 25 more bushels. Did they? Or did they allow the system to function properly, efficiency to be maximized, and at no point did anyone lose their crop? That's the point. Microbes are designed to increase efficiency. In this case, lignin and cellulose are no match for millions and millions of microbes per, in some cases, square foot. We brew up our materials, fellas, to have hundreds of millions. We guarantee 1 times 10 to the 8th, and we make them up in the first brew at 1 times 10 to the 9th. That's a 1 with 9 zeros, which in most characteristics is 1 billion microbes. And we say that's the CFUs, colony forming units, because every single microbe that can go into the ground, if it has enough food and air and water, 1 microbe today will be into the hundreds of millions or a billion tomorrow. We put 1 billion microbes in 20 drops of water. That's called a milliliter. So in a shot glass, I can have more living microbes in a shot glass than there are people on the planet. And if I deliver those out over an acre, each one of those organisms can be 1 billion by tomorrow. You can't wrap your arms and head around the numbers. It blows your mind. And that's the idea of a fence row. A fence row looks exactly like that. We go in and select out organisms in that fence row, brew them up, get the characteristics that we want, put them in high counts, and go back and take the fence row and put it in the farm row. And so when you start seeing numbers like this, it's not outside the realm of possibility. Here's 155 acres of soybeans in 2016. Once again in Iowa, soybean sudden death has eaten those guys alive. Where you put accelerate on in 2015, let them work on the stalks all through the winter, and then put the beans in there in 2016, the areas on the right side were stressed and hurt. Lots of soybean sudden death syndrome, far less incidences of soybean sudden death syndrome on our side, and you've got all those extra bushels. On the right side here in Iowa, you see the untreated area, 237 bushels down below. In the left area, 251 bushels. So they're picking up 14 bushels, nothing to sneeze at. The long-term results of most of these scenarios, somewhere around 7.5 bushels for all the tests that we've seen so far on corn, 3.2 bushels. Now that's all of the tests. A lot of the tests that come out of Iowa this year weren't even close to those numbers. If you look at organics, there are several things that we have in the picture. So for you guys that are growing veggies in there, the organic vegetable growers, these materials are registered and they're done by Washington State. I don't know what the certifier, if those certifications are allowable for you over there. Again, we talked about the complement. We kind of explained that. That's kind of an outside the situation. Convert sugars, all kinds of different types of soluble sugar compounds, many times like a molasses type product that has many different kinds. Those can be put in the furrow. They can be sprayed multiple times over the top of a crop to develop bigger roots, better production for the fruits and vegetables in terms of total organic carbon. If you've got stress situations, you can really help them work through stress. The SG fulvic is a concentrated fulvic acid, again, an organic acid that can be used the same way as the carbon compounds in the furrow as you plant, sprayed over the surface of the soil to crank up the biology. They can be sprayed as foliars over the top as carriers and do some different things to keep things stuck on the surface of a leaf rather than letting them fall off. All kinds of ways to use that. Amino acid nitrogens, excuse me, as we said before, amino acid nitrogens being the most recognized form by the plant over ammonium and nitrate. The most recognized form is amino acids. A dry flowable form that you can actually put into water and melt down, a 1300 that's protein based, and a 300 liquid. Both of those, if you already prefer liquids, and all liquids, once you get above 3%, most certifiers won't do it because they think you're pulling the wool over their eyes. So they keep it at a 3. The dry flowables, of course, can get 13 to 15%. So if you prefer to have liquid and you don't want to mess with dry flowables, you have those options. That's a lot of stuff. And that's SummitGold in a nutshell. What we do is we provide these products. We go out and talk to each individual grower, oftentimes look at their soil tests, look at the way they farm. By no means are we standing here in front of you and telling you you're going to change the way you farm. If you like the way you farm and you can find ways to fit these products in, great. If you're looking for a slightly different way to farm, we can suggest some things that are going to help improve your efficiency. But at no point should you sit here and feel like we're trying to tell you you don't know how to farm, because if fertilizers and farming the way you didn't work, you wouldn't be sitting there at that table today. So congratulations, you've made it through. As you start to look to the future with the tightness of the markets and efficiencies that have to change, what you're going to see is there's only so many differences that can be made in the old standard fertilizer programs. Using nature, changing forms, making things more available, and in some cases how you apply them is the wave of the future. And as I mentioned before, biologicals and all these products like the organic acids and the live microbes and the kelps and all these other things kind of fit into this big biostimulant realm. And it's still kind of confusing because the industry is trying to help sort out what we're going to call what things. But with $15 billion worth of that market being created in the next 5 years, trust me, it's not a passing fancy. And as your neighbors start to adopt it, it starts raising the water in the lake. And if you start to get behind, you're probably going to find yourself interested in getting started. My suggestion is, even if you're doing it on a small scale, start with it and see what kind of things are happening, because within a couple of years' time, you can see some significant changes in the way the soil is functioning, appearing, operating, and delivering the goods. Okay, so that's a lot of stuff. I can't apologize. I'm pooped out. It's been a long week, but hopefully you've got some pretty good information to be able to help you look forward to the future. So with that, I'll stop. And if you've got questions, I'll gladly answer them.
Yeah, Dan, we got a question from Clay about Accelerate.
Oh, on the Accelerate, what kind of temperatures do you apply in the fall? How long will it work? Does it die? Does it need to be reapplied in the spring?
Yeah, that's a very good question. The answer is, and especially as you go into those northern environments, you've got a much more accelerated time before winter. Winter will not kill these organisms. If you're putting something out there and your temperatures, let's say, are in the 40s and 50s when you apply, they're gonna, if they're out there, if you've got 4 or 5 days of those kind of temperatures, they're going to continue to grow like crazy and move into the plants. And once they're into the plants, they're going to be there all winter long anyway. Even if you're spraying and you get a little bit of frost will kill the ones that it hits. But if you spray it over the surface of the soil, the frost doesn't kill them all. And the next day, as the soil warms and there's a food source out there, they begin to regrow. Because as I said, if every 5 to 20 minutes they're replicating, as long as there's food source out there, which these stalks will work as a food source, they're regrowing. And when that frost melts, that ice melts, there's liquid. And where the liquid is, the microbes actually expand in that liquid. And so dew and frost and light rains are great. Worst case scenario is if you sprayed it and it went down to 0 and it didn't come back above 0 for a week or two, that could be a problem because they didn't get a chance to start growing. But if at any point it just lightly frosts over the night and the temperatures in the next day are in the 40s and 50s, even above freezing, you won't kill them. So there is no need to retreat in the spring. If you want to use them in the spring to do the carbon dioxide thing I said with photosynthesis, typically in the spring you won't get quite enough time to get them to break down and get rid of the structural integrity. When you use them in the fall and they break down the insides, you don't have hair pinning, you don't have root wadding, you get rid of all that problem. But you won't get that very easily in the spring because you don't have time to break down the structural integrity. Within 5 days of good temperatures after spraying Accelerate, the untreated side will still be stiff. If you're grabbing a hold of them and shaking them, they're still stiff. The treated side, you'll be able to grab them and bend them over. They're like rubber, and you can almost bend them over and touch the ground after 5 days. So they can get into gear pretty fast. They will be releasing carbon dioxide as a result of what we talked about with the manure and such. They will be releasing that up into the canopy in this year. So you'll give up a little bit of the inability to get rid of the hairpinning and the root wadding if you do it in the spring. But in all cases, you still get the carbon dioxide burst off of that stuff in the soil, and you can grow a higher crop with it.
Hey, Dan, one thing maybe you mentioned, and I just was sleeping, didn't hear it, but the Accelerate, you're obviously going to decompose things quicker, but within that, you're going to get more net nutrition from that organic material quicker to that growing crop the next year, right?
That's correct, Brian. Yeah, thanks for bringing that up. I did forget to mention that. That's a very good point, because in any given 150 bushel corn crop, and that's only that's only at least 3 ton of fodder. And often if you've got big tall stalks, you've got 4 or 5 ton. And if you get close to 200, 180 to 200, you've definitely got 4 or 5 ton of fodder laying on the surface. That fodder represents your a physical tie-up of your investment dollars. And there's no question, with all of the university research that's done, in that standard 3 ton, there's more than $100 worth of nutrients just sitting there looking you in the eyes. And that's typically just the N, P, and K, and maybe the micronutrients, let alone the carbon. So by breaking that down right at the surface, you're now re-inoculating the surface right at the top with nutrients from that fodder. And so it's a significant opportunity to relieve those nutrients back into the system, reclaim those nutrients. And in some cases, I mean, a lot of the fields you guys up there, you may have seen, you might have fodder and stalks from two or 3 years ago. So you never know exactly what the total is. But by breaking that stuff down and getting rid of the structural integrity and laying it down on the surface, you're regaining those nutrients. And oftentimes you're going to find there's 60, 70 pounds of nitrogen. There's 60 to 90 pounds of potassium, and typically somewhere in the vicinity of 30 pounds of phosphate just in that 3 ton of fodder. So if you lay that back down on the surface, that's going right back into the soil system for you this year.
Hey, Dan, this is Kurt. As far as putting it on in the fall or the spring, we always are going to tell guys that, if you can't get it on the fall, there still is a value in the spring. Now, you may not see it at time of planting when you talk about, the machinery and that, but you are going to obviously be getting all that nutrient release. I mean, you agree with that, right? I mean, that's where we're at.
That's right.
In the spring. Okay.
Yeah, that's not a problem. That's not a problem. The thing about it is, it won't be nutrient release, right away. It's going to come all the way through the season. So as you're looking at a soybean crop, or even if it was a corn following corn crop, it's going to be out there in the middle part of the season with a little bit of rainfall, and it's going to be right in the place that you want it, working right down into that surface, right into the roots down below the surface, and being picked up by the crop. So it's a much more efficient way to get nutrients out of that, clear up on top, and not worry about them being volatile or washing around. It's a very stable form of nutrient. Yeah.
One other thing that you might mention is the soil penetrant portion of Accelerate.
Yep. I did not mention that. There is a soil penetrant in there. The reason we put it in there is to kind of help draw the material down into the top of the soil when it hits there. and also to draw into the waxy character on those plants. It's a little bit waxy, and so when we put a soil penetrant, it will move into the wax and also quickly draw the microbes tight to it and allow them to get through the wax and into the center of that plant much faster. And then also, if it's washing off, that penetrant allows those nutrients to wash into the soil more effectively, quicker, and not be lost or washed away on the surface. So that's a good point. I can't remember all this stuff anymore. I'm getting too old.
Any other questions, Brian?
Yeah, I got one from John.
Question about the product complement. What form does that come in, and how do you keep it aerobic? I guess first, what form does that come in? Is it a liquid?
It comes in a liquid form. Yeah, it's a very, very concentrated liquid form. It's a water-based solution. It doesn't have any magic in it. It's just water that we use to carry the microbes, and we're looking at the real high numbers in that water. Yeah.
So how do you stabilize it going anaerobic then? What kind of window do you have to apply it?
Once it's inside, you're talking about now inside the jug?
Inside the jug.
Yeah, inside the jug, once it's sealed off, most of the nutrients have been consumed in the brew. So there's not a lot of nutrients in the jug. And so once they're in the jug, they're fairly settled down and stable. They're not really doing anything. And it's a fairly low, there's air in it, oxygen in it, but it's a very stable environment. Once you open the jugs and you introduce oxygen, oftentimes they'll start to grow pretty rapidly. And especially if you drop any nutrients or any soil or anything in there and provide them food, they're going to take off. Inside the jug, they will never go bad, but they're never as good as they are. When I say they'll never go bad, that means they're not ever going to go totally dead, but many of those organisms are going to die. But some of them, before they die, actually turn into a resting stage, what we call a spore or a seed, if you will, and they actually just kind of go into a suspended animation. So the product is best after it's produced fresh, really within the first 3 months of production. So we're really not producing hard yet. We're going to start here. The production has started briefly, but we're going to start ramping up. We can make 10 to 20,000 gallons a week. So we'll start that production here hard this next week coming up. So it's going to be the best in the first 3 months after it's produced, going into the soil if it's the complement organisms, going off the surface if it's the accelerate. So we don't produce lots and lots of accelerate in the spring, even though we're going to use it. We produce some, we don't make lots. We typically save that for the fall. After about 3 months, you're still in the very good category from 3 months to 6 months. Once you get from 6 months to 9 months, you're still in the good category. You get above the 9 months to the year, you're in a fair category. It's still working, but it's not working at the level it was when it's fresh. So you either have to put in a little higher rate or mix in some brand new fresh bugs with it, like maybe 10 to 20% bugs. You mix them together, you reinvigorate it and go plant it right away. It'll be fine. The other thing that's smart to do is if you buy some of these organisms that you intended to use in the spring, and let's say you overbought a little, or you got run out and you couldn't do some things and you forgot and you had a few gallons left over. The best way to use them is actually, if you're going to go out and put out some, let's say some 28% nitrogen as side dress nitrogen, use the microbes at a quarter or a half rate in the nitrogen. So many people are interested in killing everything in the field to try to keep nitrogen from being converted. That's really the exact opposite of what you should do. You should put the microbes in the nitrogen. Put a little food, some sugar or some fulvic acid, or if you've got anything laying around that's organic, and feed those microbes, let them eat that nitrogen and totally consume it in a matter of a couple of 3 or 4 days. Once you do that, that nitrogen is stabilized in an organic form and will start breaking out as the microbes die, and that process will last for weeks. And the form that they're breaking out of it in is amino acids and proteins, the most preferred form by the crop. And that's what gets you high yields and high test weight. We have gone at this thing so wrong for years, but it's the only technology that most people knew to use, and how to use it was to kill things. Just put in nitropyrin, Inserv, or urease enzymes, and let's kill this and block that and block that. if you actually let the soil eat up all the nitrogen, it will dose it back out anyway. Let's face it, if it's bone dry, you're saying, well, if it's bone dry, I'll never get anything. Well, that's not true. If it's done with wide drops and laid right over the surface of the row, even small quantities of dew and funneled dew water down to the top, if those microbes are there and that nitrogen band was there and you have liquid, you're going to absorb that stuff. So I realize it seems far-fetched, and it may sit here, and because I'm talking so fast, it may fly right over your head. But there is a method to the madness, and it's managing the biology in that soil and living and dying day in and day out, year in and year out, week in and week out, year in and year out. That's how the soil functions anyway. So if you learn to work with it, it works better with you. And then Brian, I know you've done a lot of different things, and you can talk to those guys about your different rotations. In rotations, if you put in crops that put out these amino acids into the soil, crop rotation works because legumes make amino acids that grasses like, and the more amino acids you put from a cover crop will create a slow release nitrogen program for the following crop. Grasses put out amino acids that legumes love. And so in your diversification of your cover crops, Brian, you have fed that soil entirely different for years. And I imagine some of the guys that you talk to there might be surprised at the levels of nitrogen that you might have used through the years to still grow a great crop. And that's because you're breaking out nitrogen in different forms all the time.
Are the microbes site specific or regional specific or crop specific? Do you tailor those microbes to where you're applying?
They are not. They are not designed to be any specific site. Many of the organisms that we're talking about here, guys, you have in your fields. Not all of them, but many of them. The challenge is microbes possess certain characteristics. They have the ability to do many, many jobs. We think they only do one, but they do many. The whole point is, let's go back to Bacillus subtilis. We know there are all kinds of Bacillus subtilis, and they're naturally occurring on farms. However, they are not with every seed. They are not out there in the hundreds of millions around every seed, and they are not in every row and every place where we put our plants. Our objective is harvest the characteristics that we want from these microbes. We want them releasing phosphate. We want them releasing micronutrients. We want them releasing plant growth regulating compounds that give us the biggest root masses we've ever seen. I ask people, if I take a soil test, regardless of what the numbers are, I pull a soil test, my microbes and my programs are designed to build one of the biggest root masses you've ever seen. If I double, triple, quadruple the root masses in one row and 30 inches over in another row, I don't use that technology. And on my row, I've doubled, tripled, or quadrupled the root mass, no matter what the soil test says in the middle. Which row is more efficient at picking up its nutrients? The one with the bigger root mass. Now, ironically, if you go in there and compare the soil test from the center of the rows and pull one from right down in the row where the microbes are, and you look at the numbers go up in the row. So if I have released nutrition and doubled or tripled my root mass, it's no surprise why these technologies are working and they're increasing efficiency, and you start to see some of these crazy numbers that you see, because all you're doing is returning the fence row to the farm row. That's it.
Have any of you guys done a Haney test on your soils?
Yes.
Yeah, can you touch on a Haney test just for a second, please?
Yeah, there's Haney tests and Solvita tests. Most of them are designed to look at the comparison of how biologically active those soils are. And so when they extract, when you put biology or improve things for biology in the soil, as they're working, if we go back to the picture that you have in your mind of that field in Iowa that had 5 tons of poultry manure, the more biological activity that works in that soil, the more carbon dioxide comes off into the atmosphere. So if you want to compare apples to apples, let's say you took an area that was 10 feet wide and 5 feet of it you treated with microbes, and 5 feet you left untreated. You pull out the samples side by side, you send them in, and they'll actually check for the carbon dioxide burst, how much carbon dioxide's coming off that soil. They'll give you that number. They will also estimate, by the virtue of that biological activity, a nitrogen release number as a result of carbon working in that soil and the organic matter that you have. As a result, they can calculate a score with all these numbers to help you understand, is your soil healthy or getting healthier, or is it challenged? And they'll give you a number. And so really, in the end, all you're going to do is measure those soil health numbers. That whole system is now being implemented to help people understand how to compare apples to apples. It doesn't necessarily give you numbers that you go out here and say, oh, I have an 11.2. I'm perfectly fine. That's a good number. But I know, Brian, I saw one of your numbers. You had a number that was what, 24 or 28? That's off the scale.
They went off the chart.
On a scale of 125, it was 28.
28. And, you know, those numbers are just incredible, which is telling you that the biological activity in those soils, if you get one out of the side ditch or the fence row, they're not much better than that. So they are really rocking and rolling. So really, you're not looking at a soil test as you would think a normal soil test is going to give you availability. You're looking at biological activity. There isn't any good test, guys, that you can go out there and test for the individual types of microbes in your field. They can be done on a very small scale, but they're very expensive and they really don't serve you any purpose, because all you could change all that in a heartbeat. Is all you did is just go out and spread manure or spread sugar or anything on the soil. You can crank up the level of soil activity. So it's really not impressive to know what you've got out there. You just realize that if you're in conventional till, there's far, far less types of organisms in your soil in tillage than there is in minimal or no-till, and much different than what you have in a side ditch or a fence row. If you want to impress yourself, get some of the soil from the fence row and get yourself a few flags, get yourself a bucket full of soil, go out and actually put some of that soil from your fence row over the top, lightly over the top of where some seeds are in your field, and put some flags there and come back and watch those plants through the year and watch what happens to them. They'll be very, very similar to what they would look like if you planted them and could grow them in that fence row.
Any other questions?
So back to this compliment, what is your base? What do you start with? You start with fence row, dirt, you start with a compost. What is, I assume you're making some kind of an extract or a tea to start to multiply it?
You mean to multiply them, or how do we find them?
To multiply it. Where do you find it, and how do you process them?
Yeah, finding them. Many of these organisms actually have come from soil bioremediation. We found them from all over the world. A great percentage of them are from, they're all naturally occurring organisms. There's no genetic modifications, and they can come from different places. A lot of them come from soil, Midwestern soils, Southeastern soils. We have some that come from the desert. Believe it or not, one of them comes from the Sahara Desert, and it's darn good at doing what it does, because that's a pretty rough environment. Microbe lives there. It's got some pretty neat characteristics. But we take them from wastewater. We take them from different kinds of lagoons. There's all kinds of places you can find certain things that you want to get certain characteristics. What we do is we bring them in there. We isolate them so that they are pure cultures. We grow them up. We take them in and basically freeze dry them, put them together in known quantities, and then you'll have a little vial of all the 29 or 30 different microbes that have been produced for that. You come back to a brewing mechanism, and part of our success, all of our stuff is in-house. We don't go outside to a warehouse that grows up bacteria and says, oh, we have a Bacillus subtilis. We select and isolate them all ourselves, because we do things with them specifically for bioremediation too. We take that vial, we put it in with a brew source, which has basically just a food source with some nutrients, some nitrogen and some phosphate, a little bit of potassium. And we start growing them up, and we take the slow growers first. They're separated out. We put the slow growers first, give them a food source, let them grow for 24 to 36 hours. Then we beef up the food source just slightly, put in the fast growers, and they grow so fast they finish it out. So there's almost a patented process to the way it's actually done. And we have improved our whole brewing process in the last year up to pharmaceutical grade, and we're looking to try to get the microbes. They come off characteristically now at like 1 to 2 times 10 to the 9th. We're looking to try to grow those up to 4 and 5 times 10 to the 9th. So that's saying 4 to 5 billion microbes in 20 drops of water, which takes a lot of food and a lot of patience, because that's and a lot of oxygen, believe it or not. And when these things get to the field, some of them are almost completely aerobic. They have to have oxygen. The reason there's so many in our mix is several of them we need for them to survive in anoxic, very low oxygen and slightly aerobic conditions, so that they don't leave you when the soil gets too wet. So we take some of the same characteristics that we find in aerobic or oxygen-loving organisms, and we put them into organisms that will live in low oxygen conditions, so that when it gets too wet, you don't lose
Okay, without a liquid system, can you inoculate dry chicken litter, for example? Will it survive in that for an application?
So you want to actually impregnate chicken litter with those microbes,
Yes.
and then spread it.
Yes.
You could conceivably. The best thing to do would be to inoculate it. I mean, we have certain types of microbes that we use for composting anyway, and some of the microbes in complement and some of the organisms in accelerate are also in a product that we call expel, that we kind of use in some cases for working in manure pits and things. It can be done, but you would need to kind of keep. The challenge is you would need to kind of keep the poultry manure moist. You would, the stuff that's sitting out on the surface that dries out, they're not going to do well there. So it would have to be inoculated fairly evenly on the poultry manure, kept moist, and then spread. And you'd want to do it a little bit ahead of time to allow the microbes to kind of beef up their populations before you spread it. That has not been done to my knowledge. We do treat poultry manure with organisms to get the stink down and do some other things, but I don't know of anybody who's tried to treat the poultry manure and then use it as a spreading mechanism. Actually, if you're going to use poultry manure, if you didn't want to use the complement organisms in the furrow, what you saw with that corn in Iowa, that with the 5 ton of poultry litter, you might do just as well to spread those organisms over the top of the soil, let them work themselves down in there, and you'd be better off actually doing it with that maybe than just using the complement. Use the accelerate rather than the complement. Might not be quite as good, but it would give you some pretty interesting results.
Thank you.
Anybody else? You bought out of gas, Dan?
I'm sorry?
You bought out of gas?
I'm never out of gas, Brian. You know me, I could do this for hours. I'd sit here and probably fall asleep on the computer, but I wouldn't be out of gas.
Brian has all the prices. Sorry.
Brian, what?
He has all the prices like amino acid and that kind of stuff.
Well,
Yes, Brian will have all your pricing. If he doesn't have something, obviously we'll get it to him quickly. But yeah, Brian will have anything you need on product information and pricing.
Dan, I might have a question I do have a question on wheat country out here. So we still kind of are wheat country anyway, but moving quality on wheat. I mean, we always talk about yield and whatnot, but is there any particular steps you might take to help move the protein on wheat, which is getting to be a bigger player all the time?
Yeah, Al, there's a few things you can do for the protein. I mean, it kind of depends on what stage the crop's at and what kind of time you have to impact it. One of the things is, improved levels of sulfur help stabilize nitrogen and keep it in ammonium forms longer. So using sulfur to keep soil nitrogen in the right form has an impact. And the closer you get to flag leaf and heading, the value becomes higher. So if you can make a late top dress of ammonium sulfate, for instance, it'll be stable on the surface. And both the ammonium forms of nitrogen give you yield and increase protein. And then also, if you can actually foliar feed the ammonium on the leaves. So for instance, with some of the products that Brian has, they can tell you there's a product called SG Advance, some other things, or even if you're looking at just generally getting what's the nitrogen form, something like in demand, something like a triazone urea. You can even use 28% if you use enough sugar to put on a flag leaf. Brian can tell you how to do that, but you have to put sugars on there to protect it. But nitrates will not give you improved protein. They might give you a little bit of help on green up and life, but they're not going to give you protein. They're not going to give you yield. They have to be an ammonium or amino acid form, like you were just talking about. Those have to be sprayed on the flag leaves or the heads to absorb in and be the right form to bring the test weight up, to improve test weight, give you higher yields because of test weight, and also improve protein simultaneously. The microbes themselves in the soil continue to make an ammonium form. So dead cycling microbes deliver amino acids and proteins and amine forms of nitrogen. So if you're out there making applications of, let's say, an early season herbicide, and you put some microbes in there and you develop microbial communities that live and die, that in conjunction with a later application of those nitrogen compounds to the flag leaf or the head can dramatically start improving the protein content. So the quality of wheat is how good a soil are you producing it in biologically, and how much amine or ammonium form can you put on that flag leaf and get it to absorb in. Always put sugar with that stuff and it'll help it dramatically. So, you know, it's a matter of where you're at currently with protein. I'm assuming 13, 14, 15% is about the outside. That's what locally you get?
Yeah, that would be pushing the top side. I mean, spring wheat or winter wheat would make a difference too. But then I might also ask about you talking about putting it on late like that, a protein or a, the quality is actually functional then in the seed, as opposed to just getting a test result that tells you got higher protein. I mean, that's not something that necessarily always translates into a functional protein for a miller. I'm kind of follow the sweet deal a little bit like that. But being functional is what is just important, more important than just having a quantity there, I guess.
I'm getting enough feedback. I'm having a hard time understanding exactly what all the things you were saying there. But
you talked about putting some forms of this on, move it late, like putting it on the head.
Yeah.
Is that protein also going to be functional when it comes to the miller when he gets it and uses it?
For the milling qualities. Milling qualities. Yeah, that's a very good question. I mean, they're looking at some of these things, and we did some studies, and I think Kurt and Greg can get that information to Brian. We did some studies on milling quality, and you're right. I mean, there are certain, obviously, anything that impacts gluten. The more gluten you form, the milling qualities change dramatically. And of course, that's what most of the mills are after these days. The rest of us who have family members that are gluten intolerant are kind of roughing it out, but that does change the price. So the protein, the quantity of the protein and the quality of the protein do make a difference. And we have seen where we go in with assist and shift, those products, assist put on in the ground and shift put on the leaves, have dramatically improved protein and milling qualities. And so that information, it may be kind of protected because I don't know if there's a non-disclosure agreement on that, because some of the people that are doing it are wanting to kind of control it. But anything where you get into high quality sugars with a little bit of actual amino acid nitrogen is going to change the protein and improve the milling qualities. We have some data that starts showing that. Yeah.
Yeah, that'd be interesting to see if it is available to test. So,
yeah.
Thank you.
You're welcome.
Anybody else? Kurt,
I'm impressed those guys are still sitting there. I would have thought by now they'd already melted down into their chairs. Thanks for hanging in there, guys. I realized that was a lot of information, but that's, we were missing 30 years of agronomy, and you just got 3 PhDs put in your back pocket right there. So, next time somebody asks, you're well informed.
Great. Kurt, you guys have anything to talk about?
Nothing in particular. Just reminding you guys. Obviously, get with Brian if there's questions that you forgot to ask. We'd be happy to get those answered. Brian can get us a call on the phone. We can get Dan on a conference call individually if there's a specific question. As far as products and pricing, Brian has all that information. He can get with you one-on-one if you decide you want to either get more information on a product or put in an order. Obviously, Brian can help you with that as well. Brian, I think the only product maybe we didn't talk about was the BB5 you would want to cover. Dan, would you just real quickly just give them a quick synopsis of BB5 and why they might want to use that?
Sure. I can do that, Kurt. BB5 is a product that basically is like a very concentrated phos acid. We use that when we are making spray preparations to go out to the field, especially where we have glyphosate. Unfortunately, in years past, we were able to use it with dicamba and Banvel, but with some of the new recent regulations, I don't think unless it's cleared. Now, if you're using Banvel on a non-dicamba bean or something, or corn or something, it doesn't impact that. But if you're putting it on dicamba beans, I don't think you can actually use it. But what it is all water has hard water particles in it. And hard water particles are things like calcium and magnesium and iron and zinc, all of those heavy cations. When you put glyphosate in a tank, the charge on the end of a glyphosate molecule is strongly negative. And when glyphosate is poured into a tank with hard water, the positive calcium and magnesium and iron and those elements, sodium, attach themselves to the glyphosate molecule. And even though it looks like a glyphosate molecule, it isn't glyphosate anymore, and it doesn't work. So you lose the active ingredient. So what we do is we take this product, BB5, that has some wetting agents and a little bit of sticking agents, but it has a heavy phosphoric acid base. You pour it in the water, and the phosphoric acid ties up the hard water. It reduces the pH. It has a color indicator in it. So as the pH is falling down into the acid range, getting away from hard water, it will change colors. And so what we tell people is you make the water pink, the pH will be 4.5 to 5. A lot of the hardness is gone. And then you pour in the glyphosate. The glyphosate has nothing to react with. So if you spray it on the leaf, you have a higher level of glyphosate active ingredient. If you throw in just a little whiff of fulvic acid, or SummitGold has a product called Influx that has a little bit of manganese and fulvic acid. If you throw that in together, you can rocket launch that glyphosate into that leaf and down into the sites and trick that plant by getting it in there so fast it doesn't have a chance to react. And it will kill it oftentimes a lot faster and a lot more effectively, even if it has the appearances of being a little more resistant. We've seen guys that use these technologies are able to get some much better control. It's not a product that costs a lot. I think normally, Brian, you could tell them if it's somewhere maybe around 50 cents to 60 cents an acre.
It's about 45 cents here.
Yeah, so it's not expensive, and it's very easy to use. And as long as you're not colorblind, you can always figure out when the water's pink. If you're colorblind, that might be more of a challenge, but it's a very simple product to use.
The beauty is about 90% of the herbicides that we use that require AMS, we don't need it anymore. We haven't used AMS for 20 years. So that's the beauty of it, really. Yep. You're not toting 17 bags of ammonium sulfate at the top of your sprayer.
Yep. Well, one of the things that, if you want to go back to practicality and some common sense, if you've ever seen the vinegar and baking soda demonstration where you have a strong acid, which is vinegar, and a baking soda, which is alkaline, you mix together, they have this very violent reaction where they neutralize each other and give off some carbon dioxide and la-di-da-di-da. Well, if you make a pH of water down to 4.5, and let's say, for instance, on the surface of a lamb's quarter or a kochia or a velvet leaf, if you've got that stuff working in there, the pH may be as high as 9. Well, if you take a very alkaline pH on the surface of a leaf and you have a very acidic pH in the water, when the water actually at that pH goes onto the leaf, there is this chemical attraction of these two things trying to neutralize each other, and they hold together very, very well until that reaction is done. So just by changing the pH of water on high pH surfaces, you can get herbicides to work better yet.
Okay.
Okay.
Anything else, guys? There's a lot of stuff to keep in the back of your head, so. Dan, John might be calling you, John Costa might be calling you about some more biological type questions.
Okay.
They're organic and they're using a lot of chicken poultry manure.
Oh, they are.
Yeah.
Boy, that's challenging. We got to figure out some way to get these microbes done, right? That is just such a sweet deal for anybody. There may be some ways. Talk with Greg and Kurt specifically. You can talk to me and I can tell you how to use them technically, but talk to Kurt and Greg and see if there aren't ways for you to be able to actually achieve that. That's one of those things where I think they could help you get that technology through some creative situations, as long as they're not claimed. They're not going, I mean, they already OMRI certified, so it's not like the organisms aren't allowable. They might have some creative ideas of how you may be able to get your hands on that technology.
Yeah, it's actually a South Dakota issue with just labeling. It has nothing to do with the organic certification.
Right.
But we have some ways to get that done. So we can talk about that offline, but yeah.
Sure. Yeah.
Okay. Thank you. Anybody else have any questions? Well, thanks a lot, guys. We appreciate your time.
Yeah,
All
thanks for having us, everybody. I appreciate you guys sitting down with us. And again, any further questions, Brian, I don't know if you've offered it, but if any of the guys there want anything one-on-one, specific soil tests looked at, in the next weeks or months, we can arrange that as well. This kind of a format, with us and Dan, it won't be this long, obviously, but just specific, as long as you're able to do it, Brian, we could definitely offer that up as well if that's of help, specific planning and things.
Sure enough. Thanks, guys.
Hey.
All right. Thanks so much, guys. Appreciate your time.
Bye-bye.
Thank you. So that pretty much ends the presentation.